All right, welcome. In this video, we are going to take a look at Le Chatelier's principle in action. So we're going to look at some different equilibrium systems, and then we are going to apply what we call a stress to the system and see if we can observe how the system responds to that change there. And so our first system we're going to look at is this one right here, which looks kind of complicated. So let me explain what's going on here. So I took some copper chloride. So we got copper ions, chloride ions, and I dissolved it in some water. And when you stick the copper chloride in water, what happens is some of the coppers will stick with the water molecules to form this hydrated copper. And then there's going to be some chloride ions hanging around. And then some of them are combining with chloride to form this copper chloride complex ion right here. And then we also have a bunch of waters floating around. And so this is what my mixture looks like when I combine everything together. And we can see that the solution is blue. So that means that right now the predominant form in our solution is this right here. So we have more, if we think about it in terms of our K expression, we have more reactants than products right now, right? So we have a lot of this copper hydrate. That's why it appears to be blue, okay? But we can cause what we call a shift in equilibrium to occur by changing the concentrations of some of these reactants or products. And so what we're going to do is we're actually going to add some chloride ions and see what happens. So I have some sodium chloride. So this is basically regular old table salt. And I'm going to add some of this to my test tube right here. I'm going to swirl it around. And I'm going to add a lot of it so we can see it really clearly. So what I'm doing right now is I'm adding chloride ions to my equilibrium mixture. And you might notice there's a color change happening. Maybe it's hard to see as I'm shaking it. But after I'm finished shaking it, I will pause and show you. Now, do you see how it looks green? If you don't remember what it looked like initially, let me show you the beaker of what it looked like initially. So initially it was blue, and then we added some chloride and it turned green. So what happened is because the system is in equilibrium and this reaction is kind of proceeding both directions, when we add more reactants, we add more chloride ions, this forward reaction is going to speed up, and so we're going to produce some more copper chloride down here. So we ended up turning some of this blue copper hydrate into this green copper chloride because we could have forced the reaction to proceed in this direction. So now it turned green, okay? But this is an equilibrium system, which means this process is reversible. So we should be able to do something to reverse it back and turn it back into blue. And we can do that by adding water, okay? So water is a reactant in the reverse reaction. So if I were to grab some water, I'm gonna pause for a moment and go grab some water. All right, so now I've got some water and I'm going to add, I have some water here. I have not added it yet. So right now my test tube is green because we have a bunch of copper chloride, and we're gonna see if we can make it proceed back and turn back and make some products, make some of these reactants again, make some blue stuff. Okay, so now I'm gonna squirt some water into my test tube. Have you noticed as it does that, do you see how it turned blue again? Okay, it's kind of a pale blue because it's diluted, but it's not green anymore. Now it's blue again. So what happened is as we added water to our equilibrium system, we made the reaction proceed this way. So what happens is when we increase the concentration of reactants, so we added chloride ions, we made the reaction proceed this direction and make products. And that's why it turned green. And then we were able to make the reverse happen by adding water. So we added water, the reaction proceeded this way and formed this blue original reactants again. So we can see that reactions are reversible. And this is something known as Le Chatelier's principle, where we're talking about how a system will respond to a stress. So if you add excess reactants, we say the reaction shifts away from the stress to use up those excess reactants and turn them into products. If we add products, the reaction is going to shift the other way and use up this excess products and turn them back into reactants. So that's what we just saw happen here. Okay, we're going to look at one more reaction of a shift in equilibrium. And this time we're looking at this system that involves cobalt and chloride and water. This is very similar to the copper system we just looked at. So there's a cobalt hydrate where there's cobalt combined with water, and that is pink. And that's what this looks like right here. And then there's also some chloride ions floating around here, and the cobalt chloride version of this is blue. We can't see that right now. And then there's also some water. So we have all forms of this floating around the system. We've got chloride ions, we've got water, we've got some cobalt chloride, we've got some cobalt hydrate. It looks like right now the solution looks pink. So we've got mainly cobalt hydrate. We don't have very much cobalt chloride there. But notice how this reaction also involves heat. So this process is endothermic. It uses up heat. So what that means is if we were to put this in a hot bath, that's what I'm going to do right now. This is some hot water right here. It's kind of like we are adding a reactant to our equilibrium system here. And so we're going to observe that the reaction is going to shift to use up that excess reactant. So when you add heat, we're going to see this reaction proceed to the right and form these products. So it's going to form cobalt chloride and water. We can't tell it's making water because there's a bunch of water there, but look at this. Have you observed this color change? Wow, now it turned blue. So when we added heat, the reaction shifted to form more products, to use up that excess heat reactant and form products, okay? It makes that forward endothermic reaction maybe more favorable, and so we end up making more of this product right here. And since this is reversible, we should be able to make this go back the other way. So here is my ice bath. This one might take a little bit longer, but what we're doing here is when I put it in the ice bath, I am removing heat. So I'm basically taking away a reactant. And so the system's going to respond by proceeding back in that direction to form more reactant. So another way you can think of it is since we're removing heat, then the exothermic process becomes more favorable. So it's going to go in the reverse direction. And here you go. You can already see this color change happening. It is turning back to pink. Okay, so when we have an endothermic reaction like this, adding heat makes the forward reaction progress more. Removing heat will reverse that. And then we'll see the opposite if it were an exothermic